Hi everyone, in this video we are going to look at writing chemical formulae using prefixes. So this will be a nice quick video hopefully which will show you a slightly different method that's needed in chemistry for writing chemical formulae. So some chemicals that we have contain prefixes. Now these prefixes come from the Greek language and they represent numbers. Now the one thing that you need to remember, the really important thing that we need to remember is that when we have one of these examples, we do not use the valency rules. We don't use SVSTF or any other method. We simply translate the name to give the formula. So in order to translate, we need to learn what these prefixes mean. So the prefixes, we can just kind of rattle through nice and quickly because you've hopefully met these before. So number one, we use the prefix mono. Kind of looks a bit funny. Let's try writing that again. So number one, we use the prefix mono. For number two, we use the prefix di. Number three is tri, and number four is tetra. Now there are a few more. The good news is that after that they follow the same prefixes that we use for the shapes. So number 5 is pent, like pentagon, then hex for 6, hept for 7, oct for 8, and so on. You obviously need to learn these four. There are a few examples in our everyday language that can help you to remember them. So Monopoly, for example, the board game where you try to be the one person that rules the board. Mono meaning one or only. Di is very similar to bi, so things like bicycle, for example, having two wheels, comes from the same kind of language, if you like, but we use di in chemistry. Tri should be very, very familiar to you, a three-sided shape being a triangle, a three-legged race that we have, not three-legged as in what you used to do at sports day, but if you were to do a swim and then a bike and then a run, that would be a triathlon. Okay, so a 3 being tri, and then 4 is tetra. There's not really any great examples for that other than the old computer game Tetris, but we'll save that for another day. So mono, di, tri, and tetra. What we're going to do is jump straight into some examples to show you exactly how this works, because there's very little for you to actually do. All you need to do is know the symbols for the elements in question, so using your periodic table if you're not sure what they are, and translating the prefixes to tell you how many there are. Now if there's no prefix at all, then there's one of them, okay? There's only going to be a prefix if there's more than one of them, or if in the first couple of examples you see here, there's two versions of a chemical containing the same two elements, so each one has its own name. So carbon monoxide and carbon dioxide are both chemicals containing carbon and oxygen, but the mono and the di as part of these names tell us how many oxygens there are in this case. So carbon monoxide, the mono part of carbon monoxide means 1. So this is literally carbon with 1 oxygen, that's what it means. And so we write that as CO. And that's it, it's that simple. For carbon dioxide, di meaning 2, well, carbon with 2 oxygens, we would write that as CO2. Remember, the number comes after the symbol for the element it's representing. So in this case, 2 oxygens being O2, the 1 carbon being C. Nitrogen monoxide, well, nitrogen monoxide is just NO, because the mono meaning 1. And then another chemical here, dinitrogen tetraoxide. Quite a rare example in that it has 2 prefixes. It's telling you that there are 2 nitrogens and that there are 4 oxygens. And so this case would be N2O4. Now, the reason I was so careful to stress at the beginning about not doing the SVSDF method is that the D as part of SVSDF is to divide, and whenever you've got prefixes, you do not do the division step. This chemical name tells you that there are 2 nitrogens and 4 oxygens, so it would not be appropriate to simplify that down to NO2. Okay, NO2 is a chemical which does exist, and it's called nitrogen dioxide. okay? So it would not be appropriate for us to simplify down NO2 from N2O4. N2O4 being the correct formula for dinitrogen tetraoxide. Now, you've got an opportunity to re-watch that video if you need to, have another scan through just to kind of clarify in your head the process that you need. But what we're going to do now is give you an opportunity to have a go at a few examples yourself. So what I would ask you to do is to pause the video now and then to have a go at the examples that are given to you. The good news is that one of them was in the previous part of the video, but it gives you an opportunity to just work through the skill of having a go at these yourself. So pause the video now, and when you're done, you can come back and see the answers. Okay, so let's just go straight into it. Carbon tetrachloride, the tetra part of tetrachloride being 4. Carbon is C, chlorine is Cl, and we are saying that there are 4 of them, so CCl4. Phosphorus trihydride, well, the tri being 3, phosphorus is P, hydrogen is H, and we're saying that there's 3 of them, PH3. Nitrogen monoxide we've met already, nitrogen and oxygen, 1 of each. Sulfur trioxide is SO3, with the tri being 3. The alternative to trioxide is dioxide, and in this case SO2 would be the chemical formula for sulfur dioxide. So that's just a quick run through of how to do chemical formulae using prefixes. If you have any difficulties at all, feel free to reach out to your chemistry teacher and ask for some help. But hopefully you found that quite straightforward and quite a useful process to go through. And hopefully you'll be able to get some examples done on your own without too much difficulty. Okay, hope you found that helpful. Thank you very much and have a great day.